Wow, so we've been talking about parallelograms. We started the week by saying that they're parallel. Remember, opposite sides were equal. They had the same slope. We talked about that at the beginning of the week. Then yesterday we even talked about that opposite angles. Remember, the angles add up to 180, adjacent angles on a parallelogram. We talk about in the proofs that. So we learned something, but there's something pretty cool about the diagonals as well. Now the diagonals have an interesting part. In a parallelogram, you see how I have two diagonals. One of my diagonals is DB and another diagonal is CE. Now, those two diagonals don't necessarily equal each other unless my parallelogram is a rectangle as well. So if it is a rectangle, those two diagonals are going to be equal to each other. Now, if it is not a rectangle, those two diagonals are not necessarily equal each other. However, there's something really cool that happens. The diagonals cut each other in half. Okay, so what I mean with that is the segment CR is equal to the segment RE because the green diagonal was cut in half. Another thing that I know is the segment DR is equal to the segment RB. Why? Because the yellow triangle was cut in half. Something really cool. Okay, now that I said that, let's see what we have here. We have to solve for x. In each figure is a parallelogram and deal with diagonals here. The segment RB, so I see here, the segment RB, so from R to B is 10. So I'm going to say this is 10, and guess what? This is 10 as well. Because remember how I said the diagonals cut each other in half? So I'm going to start with the segment that it's all numerical. I'm giving you two segments, and usually one of them is all numerical. That's what I'm going to start with. And then I have another thing here. The segment DB, but how big is the segment DB? Well, from D to B. So basically all of this, the segment 2 dB is 2 plus 9x. Okay. But isn't the segment dB 10 plus 10? So can I just say 2 plus 9x is equal to 20? Because look, dB is the whole segment, but that's also 10 and 10 combined. Cool. I can solve for x here. Let's see. Let's separate through the equal sign. I want the 9x by itself. So the plus 2, I'm going to move it over as a minus 2. So I get that 9x is equal to 18, right? 20 minus 2 is 18. Let me divide both sides by 9. 'Cause 9 divided by 9 is 1. So 1x is equal to 18 divided by 9 is 2. So x is equal to 2. Cool, that's not bad. I'm gonna be working up to question number 11. So let's take a look at question number 9. Let me start with this thing that right here, the segment that it's all numerical. So SX is 7. So this is 7. So I'm gonna say SB is also 7. Now, some of you guys might be like, what if I didn't give you SX equals 7? What if I said XV is 14? Well, basically, that's the same thing because XV is the whole segment. But remember how diagonals cut each other in half? So I will cut 14 into two halves. So 7 and 7. So it is the same thing. SX equals 7 is the same thing as XV equals 14. What I'm trying to say is some of your homework, I might give you the information that gives you half of the diagonal. Some cases I'm going to give you the whole diagonal, and I expect you to cut it in half. Okay, now let me take a look at the segment that we have here in numbers or letters. 4x plus 2. What do you know about the segment VX? How big is the segment VX? 14, right? So can I rewrite this as 14 is equal to 4x plus 2. Because I know Vx is 14. Okay, so I can easily solve for x now. I want the 4x by itself, so this plus 2. Let me move it over as a minus 2. Don't forget to switch the sign. So I have that 12 is equal to 4x. Let me divide by the number in front of 4. So that gives me 1x. 12 divided by 4 is 3. So x is equal to 3. Okay, let's take a look at question number 10. In parallelogram PQRS below, QT is negative 7n plus 1. ST is 8n plus 31. Okay, so I don't see a segment that is all numerical. Okay, not a big deal. Let's take a look at this information here. QT is negative 7n plus 1. So from Q to T, this is negative 7n plus 1, and this is negative 7n plus 1 as well. TS is the same thing, right? Because my diagonal was cut in half. And then ST is 8n plus 31. What do you know about ST? How big is ST? From S to T. What do you know about ST? Well, it is negative 7n plus 1, right? So instead of writing ST, let me write this as negative 7n plus 1 equals 8n plus 31. Fine, if I have n's on both sides, I'm just going to let them equal each other. That's basically what I have here. I'm going to move the negative 7n to the other side as a plus 7n. The plus 31, I'm going to move it over here as a minus 31. Don't forget to switch your signs. So on the left side, 1 minus 31. Use a calculator if you need to. I get negative 30. I know 8 plus 7 is 15. So 8n plus 7n is 15n. Let me divide by the number in front of the letter. So let me divide by 15. That way I get 1n. I know negative divided by positive is negative. My answer is going to be negative, and it's fine. 30 divided by 15 is 2. So n is equal to negative 2. Don't forget that on my answer, I'm just going to type in negative 2. Let's take a look at the information here. I look at one of my statements. It's not all numerical. All numerical means it's just one letter, one number. The other statement is not all numerical. Okay, so that's fine. Which one's the small one, actually? AC is 6A minus 10. But AC is this whole thing, AC. So I'm going to say this whole thing is 6A minus 10. And then the other segment is CE. So from C to E, that's only half of it. This is 4A minus 12. So I'm going to say the segment AE is also 4A minus 12. Because remember how the diagonal is broken in half? So having that said, I'm going to say 6A minus 10 is equal to 4A minus 12 plus 4A minus 12. Right? The red is the whole thing, right? Is equal to the two little ones. All right, so let me simplify things out. On the left side, I have 6A minus 10. On the right side, when it comes to letters, 4A plus 4A, I'm going to call that 8A. Number-wise, negative 12 and negative 12, I'm going to call that negative 24. Okay, so I'm going to cancel one of my A's. I'm going to move one of my A's. I'm going to move the 6 to the other side as a negative 6A. My negative 24, let me move it over as a plus 24. So negative 10 plus 14, negative 10 plus 24, I mean, it's 14. 8 minus 6 is 2, so this is going to give me 2A. Let me divide both sides by 2, so I get that 7. It's equal to A. Not bad. There, you can see what we did today.